Alright, welcome to part 2 of the midterm review video key, and we'll get started off with the next question here. And in the next question I have a polynomial raised to the power 2, and that simply means that I need to expand this. So this will be 3x minus 2 times 3x minus 2. Okay, so this square just basically when you have this 2 here, it just means you need 2 sets of 3x minus 2. After that, you want to just FOIL everything. So 3x times 3x is going to be 9x squared, and then 3x times negative 2 is going to be negative 6x, and then you need to multiply the inside terms as well. So negative 2 times 3x is going to be negative 6x, and negative 2 times negative 2 is going to be positive 4. Alright, so if I simplify this, this will be 9x squared, and this middle term, that's going to be negative 12x, and this will be positive 4, and that's your final answer. Okay, so there it is. Let's move on to the next one. Question number E. For question number E, I see this exponent there to the power 2, so that means I need to times the brackets by itself. So this will be x minus 1 over 3 times x minus 1 over 3. And we just need to FOIL this out. So x times x will be x squared, and then x times negative 1/3 will be negative 1/3 x. And then if I times the middle guys, I'll be negative 1/3 x. And negative 1/3 times negative 1/3 will be positive 1 over 9. And if I combine the middle terms there, because there's x's on both those terms, this will be x squared, and then negative 1/3 minus 1, well basically negative 1/3 minus another negative 1/3 will be negative 2/3 x plus 1 over 9. Alright, so over here the denominators are the same, so we just combine the numerators, right? So negative 1 minus negative 1 will give you this negative 2. Okay, so that's your final answer for that question. Let's move on to the next one here. Alright, so in this one we have 3 terms on this second polynomial, but we still apply the FOIL steps. So it'd be x times x squared, and that's going to be x cubed. Sorry, that didn't come out very well, so let me try this one more time. It'll be x cubed, and then x times negative 3x will be negative 3x squared, and then x times 5 will be plus 5x. Okay, and then we do the inside terms, so this will be 4 times x, which will be positive 4x squared, and then 4 times negative 3x will be negative 12x, and then 4 times positive 5 will be positive 20. And after that, you just collect like terms. I don't have any x cubed, so I can start off with x cubed there, so that's done. And then I have this negative 3x squared and this positive 4x squared, so that's going to be positive x squared. Alright, so those guys are done. And then I can combine these guys. 5x minus 12x is going to be negative 7x, and then positive 20, that's the leftover term. Alright, so there's your answer for that one right there. Okay, let's move on to the next question. G. Okay. One of the very first things you can do for a question like this is that this 5 on the outside, you can just distribute that into the first bracket. So you would get 5a plus 5, and that's all in a bracket. Bracket a minus 1, and once again you just need to FOIL this out now. So 5a times a, that's going to be 5a squared. It's a squared because there's an a term and a term, right? So a variable times a variable is the variable to the second power. And then I would do 5a times minus 1, which would be negative 5a. The inside term, that's going to be positive 5a, and then 5 times negative 5 is going to be, 5 times negative 1 is negative 5. And then you can see that the middle terms here, negative 5a plus 5a, that will cancel out. So your final answer will be 5a squared minus 5. And this minus 5 is just this last 5 there. Okay, so there's your answer for that one. Alright, let's move on to question number H now. Okay, So the first thing I'm going to do here is I have three polynomials, 1, 2, and 3. And what I'm going to do first is I'm going to FOIL out the first two brackets. Okay, so let's FOIL that out first. This will be x times x, which is x squared, times, so then we have x times -1, which is negative x, and then that will be positive x, and this will be -1. Put that in a bracket. And then I'll put this in another red bracket here, which will be x squared plus 1. Okay. I notice that the middle terms, they will just cancel out there. Negative x plus x is 0. So now I have x squared minus 1 times on to this other bracket, which is x squared plus 1. And from here, we just FOIL again. So x squared times x squared is going to be x to the power of 4. This times this will be plus x squared. And then the inside terms, that will be negative x squared, and then -1 times positive 1 is going to be -1. And then I notice that these terms, the middle terms here, they'll cancel off because positive x squared minus x squared, that's like positive 1 minus 1, they just cancel off. And I'm left with x to the 4 minus 1. Final answer. Okay, next question, I is a little bit of a longer question because there's a power of 3 there, so that means you need to multiply this out 3 times. X minus 5 times x minus 5 times x minus 5. And then I need to FOIL out the first terms. So x times x is x squared, and then x times -5 is -5x, and then the middle terms will be -5x, and then -5 times -5 is positive 25, right? And then I have this other x minus 5 term over here that just carries along. Okay. Now, before you move on to the next steps here, I would highly recommend that you collect the like terms. Usually, the middle terms you can combine those. So this will be x squared. So if you owe your mom $5 and you owe your mom another $5, and you owe her $10 in total, plus 25. Put that in a bracket. X minus 5. And now we need to FOIL this out one more time, starting with this x squared term. So I take that x squared and I multiply that with this x, and that gives me x cubed. And then I take this x again and multiply with the -5 this time, and that will give me -5x squared. And then take my second term. Let me just erase all of this now, and I take my second term, which is -10x, and I multiply that on with the 5, which will be -10x squared, and then -10x times -5, which would be positive 50x. Alright, so that one's all done. And then I finally focus on my 25 here, and I FOIL that in. This will be positive 25x. And then finally I do 25 times -5, which will be -125. Okay, and then from here on you just need to collect the like terms. So let me just highlight the like terms there. There's a -5x squared and a -10x squared. So this will be x cubed minus 15x squared. And then I can combine my 50x and my 25x, and that's going to be $50 plus $25 is going to be $75, and minus the 125, and that should be it. That's your final answer right there. So that was a bit of a long one, so make sure you practice that one as well. Alright, so the next few questions I need to expand, and then I need to simplify. So basically, when you want to expand something, you want to distribute your outside terms, this 4x, and you want to rainbow that into everything into the bracket. That's called expanding. And over here I have a -4, and I need to rainbow that into everything as well. Okay, so moving back to this expression right here, 4x being rainbowed on into that bracket, that's going to give me 4x to the power of 3 minus 12x squared. Okay, and then if I focus on this bracket now, I need to distribute that -4 into the bracket, so that will be -12, because 4 times 3 is 12, so -12x squared, and then -4 times I have a -4 times -2x. That's going to give me a positive 8x. Okay, and then if I want to simplify, I just need to combine the terms here. Negative 12x squared minus 12x squared is going to be negative 24x squared, and then plus the 8x and then the 4x cubed in front, and that should do. That's your final answer. Okay, moving on to the next question here, and in this next question, there's kind of a small typo here. These x's that I'm highlighting here in yellow, although it looks like the variable x, it actually represents multiplication. So I'm just gonna change those with a red dot. So those red dots mean multiplication there. Okay, so if I go ahead and expand, I have my 2/3. And this 2/3 is going to distribute into the brackets here, the first set of brackets. So in order to do this, I do 2 times 18, which is going to be 36. And then I do 3 times 4, which is going to be 12. And then you have the variable x that tags along. Okay. And then there's a minus sign, so the minus sign comes there. And then let me just delete all this now. Sorry, this multiplication. And then this 2 will distribute onto that guy now, and then 2 times 2 is going to be 4, divided by 3 times 3, which is going to be 9. Alright, so that's going to be my first bracket right there. 36 over 12x minus 4 over 9. And then I take my 1 over 4 on the next set of brackets, and that will distribute right into everything in that bracket. So 1 times 1 is going to be positive 1 over, and then 4 times 6 is going to be 24, and then we have this x that tags along, 1 over 24x. Okay, and after that, this 1 will go on to that 3, and this 4, well, this is actually 3 over 1, so 1 times 3 will be 3, and 4 times 1 will be 4, so just minus 3 over 4 at the very end. And after this, all you have to do now is you just need to combine the like terms. So this and that, if you combine those together, what you need to do is you need to have the same common denominator. So if I change this 12 now to maybe a 24, I can times it by 2, so that'll be x, and that'll be 72x. And then plus 1 over 24x. If I combine those, that's going to give me a total of 73 over 24x. Okay, so that's what happens when I combine those two yellow terms. So let me just delete this and put this over here again. So this would be 73x over 24. So that's combining this fraction and that fraction. Okay, and then finally you want to combine the negative 4 over 9 and the negative 3 over 4. And I'm just going to jump to the final answer there, but if I combine those, that's going to be negative 43 over 36. Okay, so in order to get that answer there, all you have to do is, negative 4 over 9 minus 3 over 4. Make sure you have the same common denominator, which is going to be 36 in this case. In order to get a 36, I got to times the 9 by a 4, so I got to times that by a 4, so that will be 16, and times that by 9, times that by 9, that's going to be 27, and negative 16 negative 16 minus 27, that's going to give you the negative 43. Alright, so a lot of grade 8 fractions over there in order to get that answer there. Okay, so that one took a little bit of time, but let's move on to the next one here. Find the area of, sorry, let me just zoom out here. Alright, so for question number 8, I need to find the area of the figure. Alright, so for this question, I have an x here, which represents this length. And because you see these symbols here, that means this symbol and that symbol are equal. So this length is equal to that, so this is also going to be x. And one other piece of information that would be very useful is finding this blue length. Alright, so if I know that this entire length over here is going to be x, and if this is going to be y, this length right here is going to be x minus y. And hopefully that makes sense, because the entire length is going to be x, and this entire length is going to be y. So in order to get like this part of the length, I need to take the full x and subtract it from that y. Okay, let's erase that. Let me just put this as x minus y over there. Okay, so let's go ahead and just calculate the area of this yellow piece right here. That's just a rectangle, so length times width. This could be your length, x, and that could be your width. So that area is going to be length times width, which is going to be x times y. So this area is simply going to be x times y. And then I need to find the area of this blue region. And this blue region isn't too bad, because this is also a rectangle, so length times width. This is your length, and your width is going to be this distance here, which will be y, right? So that area is going to be length times width again, so length times width, which is going to be x minus y, which is that guy right there, times the width, which would be y, which is this guy right there. Okay, so this is these are my two area expressions right there, and now I need to add them together, right? So if I add them, that's going to be xy plus bracket x minus y with the y over there. And if you want to rainbow this, you can. This is the same thing as just going, you know, xy minus y squared plus xy, and then you'll see that this and this are like terms, and that's going to be 2xy minus y squared. And that's how you finish off that question. Okay, let's move on to the next few questions here. Question number 9, divide each polynomial. Okay, so for questions like this, when you see things like this division sign right here, divide the numbers with the numbers and the letters with the letters. Okay, so right away I have I see a 54 and a -9. So ask yourself, what is 54 divided by -9? Well, that's going to be -6, because 9 goes into 54 6 times. Okay, so I will put a -6 to start there. I'll delete this because I need some room for the next calculations here. And now I have a to the power 5 and a to the power 3. So if you have a to the power 5 divided by a to the power 3, remember, if the bases are the same and if you're dividing, all you have to do is subtract the powers. So this will be a to the power of 5 minus 3, which is going to be a squared. So that's going to be a squared. Then over here, you know, you have b squared over b cubed, and although you can subtract the powers, like b to the power 2 minus 3, which equals to b to the power minus 1, this b to the power of minus 1 means you have 1b on your denominator. Okay, and if that wasn't very clear, then I think another way that you could do these kind of questions is just expand the top. So b squared is the same thing as b times b, and b cubed is the same thing as b times b times b. And you'll notice that those will cancel off, and you're left with one b on the bottom. That's where that b comes into play. Okay, so this is your final answer for that question there. Okay, let's move on to the next one here. Question number B. All right, so I noticed that on the numerator I have 3 terms, 1, 2, and 3, and then I have 1 term on the denominator. Okay, so a quick way to kind of get this problem going is you can write, you can take this blue denominator and you can divide that into each individual numerator piece. So I can do, the first numerator piece is 16m squared n to the power 6. I can divide that by -16 m squared n cubed. Okay, and then there's a minus sign here, so I can put a minus sign there, and the next piece is going to be 32 n to the power 3 n to the power 5 all over -16 m squared n cubed. And there's a plus sign over there, so that's going to be plus 48 n to the power 4 n 4 divided by -16 m squared n cubed. All right, and after that, all you have to do is just simplify each expression here. So 16 divided by -16, Well, that's going to be negative 1, right? And then I have m squared divided by m squared. Well, they're the same thing, so those things just cancel off. And those things cancel off. And then I have n to the power 6 divided by n to the power 3. Well, I have more n's on the numerator, so that's going to be n cubed. So negative 1 times n cubed is just going to be negative n cubed. Okay, and hopefully this n cubed isn't too bad, right? It's kind of like you have 6 n's on the numerator, 4, 5, 6, and you have 3 n's on the bottom. And basically those just all cancel off, and you're left with 3 n's on the top, and that's how you get that n cubed. Okay, so hopefully that wasn't too bad. Let me just erase this now. Okay, continuing on here, I have a negative sign and a negative sign, so two negatives become a positive. And then ask yourself, what is 32 divided by 16? And well, that's going to be 2. And then next piece is n cubed divided by n squared. Well, you have 3 m's on top and 2 m's on the bottom, so that means you have 1 m on the numerator. And over here, n to the power 5 divided by n to the power 3, that means you have 2 n's left on the numerator. Finally, I have a negative and a positive and negative, so that means the negative sign will win. 48 divided by 16, that's going to give me a value of 3. 16 goes into 48 3 times. And then I have m to the power 4 divided by m squared, so that's going to be m squared. And then n to the 4 divided by n to the power 3. I mean, n to the 4 over n to the power 3 is the same thing as n to the 4 minus 3, which is just n to the power 1, so just 1 there. And there you go, that's your final answer for that question. Okay, let's move on. Question number 10 here. Alright, so for question number 10, the concepts are still the same. I just feel like the expressions are just getting longer. Okay, so let's continue with let's take this 3x here and let's just rainbow this right through. Alright, so this will be 3x cubed minus 9x squared plus 9x. Okay. Now there's a minus sign right here in the middle here, and what we're going to do is we're just going to put the minus sign right next to that red 9x, but what we should do first is we should just distribute the 4x onto the brackets, and then we're also going to distribute this negative sign onto that x and that positive 2, and then we're going to take care of this negative sign. Alright, so what I'm going to do here is I'll put this square bracket here. So this square bracket is the same thing as this square bracket there. And let's go ahead and distribute that 4x now. So this will be 4x cubed minus 12x squared plus 16x. And then if I distribute the minus sign here, this will be negative x minus 2. And then we'll finish this off by putting a square bracket right there. Okay. Alright, what I see here is there's a 16x and a negative x. If I combine those, that should be 15x. So 16 minus 1 is 15. So I'm going to erase this and change that to a 15. X and then minus the 2. Okay. Alright, the next thing we're going to do is I have to distribute this minus sign now, so let me put this in blue now. This blue negative sign, now we have to rainbow the negative sign into everything into the brackets there. So this will be negative 4x cubed plus 12x squared minus 15x plus 2. Okay, so once I put that minus sign right through the expression, all the signs change. Alright, and then I can just recopy this down here. 3x cubed minus 9x squared plus 9x. Alright, let's just collect terms now. So I have 3x cubed there and negative 4x cubed there. That's going to be negative x cubed. Alright, And then I have this negative 9x squared and this positive 12x squared. That's going to be positive 3x squared. And then I'll take this negative 9x and this negative 15x, those green terms. If I combine those, that should be negative 6x. And finally, this plus 2 that just tags along at the very end, plus 2. And there's your final answer. Alright, so move on. Question number B. For question number B, I have a situation where I have to FOIL. So x times x is x squared. X times negative 2 is negative 2x. 4 times x is positive 4x. And 4 times negative 2 is negative 8. Now there's a minus sign there, so I'll put a minus sign right here. And you gotta be careful with the next step here. I'm gonna put a square bracket here because I need a FOIL first. So x times x is gonna be x squared. X times the 3 is gonna be positive 3x. This will be negative 3x, and then minus 9, and then I'll put a closed bracket right there. Alright. Okay, so let's go ahead and collect some terms here. If I collect those terms there, this will be x squared plus 2x minus 8. The minus sign here, and then a square bracket. Okay, so I have x squared there, and then I can definitely combine these guys, 3x minus 3x. Well, that will just cancel off, and then I have minus 9. Okay. Alright, next thing I have to do now is I need to distribute this blue negative sign. So if that just rainbows right into that bracket, I'm going to have negative x squared plus 9. Okay, and then everything else over here can just copy down. X squared plus 2x minus 8. And then let's collect terms again. This x squared and that x squared will cancel off. And then this negative 8 plus 9, that's going to be positive 1. So my final answer here is going to be 2x plus 1. Okay, so actually I'll just put that over here. This will be 2x plus 1. Okay, let's move on. Question number C. Alright, question number C. A lot of terms to question number C, but we have to FOIL once again. So taking this this term right here is 3xy. If I multiply that with that, that's going to be 9x cubed y. And then if I take this 3xy and multiply that the next term, that's going to be minus 12x squared y squared. And finally, that 3xy with that positive 3y squared will be positive 9 xy cubed. Alright, so that's the FOIL steps for that 3x. Let me just erase that. Now I need to highlight this this positive 2x squared y, and I need to rainbow that through. So that's going to be positive 6x to the power 4y, and then this 2 and that negative 4 is going to be negative 8 x cubed y squared. And then finally the last term here, that's going to be I guess that's going to be positive 6x squared y cubed. Okay. Alright, the next thing I see is this negative 4x. And that negative 4x I'll just tag along right here. So that's that negative 4x right there. And then I'm going to put the square brackets next to it. And then let's deal with this 3x right here. So if that 3x distributes onto the brackets now, that's going to be 3x squared plus 6xy. And then I have this minus 2x, and if that distributes onto everything, that's going to be negative 2x squared plus 6xy. And then I'll close off the brackets there. Okay, so the next thing I'm going to do now is I'm going to, well, let's combine these terms right here. This positive 6x and this positive 6xy. That's going to be 3x squared plus 12xy minus 2x squared. I will put that all in a bracket. The negative 4x can tag along. And I think everything else will just remain the same here. I don't see any like terms, so I guess this will all just come down. Okay. All right, let's go ahead and distribute this negative 4x onto everything into the brackets there. And if I do that, I get negative 12x cubed minus 48x squared y plus 8x cubed. Oh, I guess I kind of forgot I could just combine I could just combine those guys now. So if I combine those guys, that's going to be negative 4x cubed minus 48x squared y. And then I guess I have to just bring everything down here. This will be negative 12x squared y squared plus 9xy cubed plus 6x to the 4y minus 8x cubed y squared plus 6x squared y cubed. I'm just looking around here and I don't see a whole lot that I can combine here. Okay, let's move on to question number C now. Now for question number C here, this one, just by looking at it, it looks like this will be a very long question here. I'm going to highlight this 3xy because I need to foil that. So I'll do this in blue here. So 3xy times 3x squared is going to be 9. X to the power 3y. And then if I foil the next term, this will be negative 12x squared y squared. And then if I foil again, that's going to be positive 9xy cubed. Alright, let's delete that, and let me highlight this positive 2x squared y. And then if that distributes over here, that's going to give me a positive 6x to the power 4y. And that will give me a negative 8 x cubed y squared. And if I do this last one here, that's going to give me positive 6x squared y to the power 3. Okay, the next thing that I will do is I'm going to highlight this negative 4x, and I'm just going to copy that right down here in red. And then I'm going to put the square brackets right next to it, and then I need to distribute this 3x onto the next terms. So that's going to be 9x squared plus 6xy. And then I'm going to highlight this negative 2x, and then we're going to distribute that right through. So that's going to be negative 2x. Sorry, I made a mistake over here. This should be, let me just delete all of this. Okay, so, sorry, if I go back to this step here, this 3x times that x, that's going to give me a positive 3x squared plus what is that, 6xy. And then this negative 2x will distribute through, so that will be negative 2x squared. And that'll be positive 6xy. And then I'll have the square brackets there. Okay, and then I can combine this term and that term. So that's going to give me 3 minus 2 is going to be just 1, so 1x squared. And then if I combine that and that should give me a positive 12xy. Okay, so with that, I'm just going to delete all of this, and I'm going to insert this into the expression now. Just x squared plus 12xy, and then I'll close out the bracket, and then I'll distribute everything in here. So that will be negative 4x cubed minus 48x squared y. Okay, and then after that, I guess I will write all these blue steps down again. 9x cubed y minus 12x squared y squared plus 9xy cubed plus 6x to the 4y minus 8x cubed y squared plus 6x squared y cubed. Okay, at this moment I don't see any obvious like terms right now, so I think we can leave our final answer like this. Okay, let's move on to the next question then. Question number 11, simplify. Okay, so I see a 2 there and a 3 there, so let's distribute the powers first. So if I distribute that 2 into everything in this bracket, that's going to be, well, 2 to the power of 2, that's going to give me 4, and this will be x to the power of 4y squared. I'll put that in a bracket there, and then this 2 will just tag along, times, and then I need to distribute this 3 onto everything in that bracket. So if I distribute the 3 onto the 4, that's going to be 64. 64 is just 4 to the power of 3, that's going to be 64. And then x to the power of 3 times 3 is 9, and then y to the power of 3, all divided by 4x to the power of 5, y to the power of 7. The next thing I would do is I would take this 2 and times it with that 4. So 2 times 4 is going to be 8 x to the power of 4 y squared times 64 x to the 9 y to the power of 3 all over 4x to the power of 5 y to the power of 7. Okay. Alright, there's different ways we can do this. I'm going to go ahead and I'm going to combine the variables in the numerator. Since I'm multiplying here, I just add the powers here. So 4 plus 9 is going to be 13, x to the 13. And then I have this y squared and this y cubed. That's going to be y to the power of 5. And then 8 times 4, that's going to be, 8 times 64, that's going to be 512. All over 4x to the power of 5, y to the power of 7. Okay, and then I can divide the terms. So x to the power 13 divided by x to the power 5. That's going to be the same thing as 13 minus 5, and that's going to give me 8. So that's going to be x to the power of 8. And then if I look at this y to the power 5 and this y to the power 7, I'm definitely going to have more y's on the denominator, so I'll have 2 extra y's on the denominator. And then finally, 512 divided by 4, if you calculate that out, that's going to be 128. So 128 x to the power of 8, and y squared should be your final answer on that one. I'm just checking to see if I made any mistakes here. I don't see any. And there you go. Let's move on to the next one. Factoring now. Find the GCF of this expression right here. Okay, so when you're finding the GCF, I would first highlight the numbers. So my numbers are 10, 5, and 15, and the biggest number that I can take out of 10, 5, and 15, it would be just 5. And then the next thing I would do is I'll look at the s values, or the s variables. S to the 4, S to the 5, and S to the 3. The maximum number of s's that I can take out will be x to the power of 3. And then I look at my t's, and the maximum number of t's I can take out are 4, so that would be t to the power of 4. And that is my GCF right there. Moving on. Factor out the greatest common factor out the greatest common factor from 12abc squared plus 28ac plus 36ac. Okay, so once again, let's highlight the numbers first and ask yourself, what's the biggest number that I can take out of the 12, 28, and 36? And the biggest number that I can take out is going to be 4. Right? I can't take out a 6 or a 12. 4 is the biggest number that factors evenly into all three of those numbers. And then I have 1a here, 1a there, and 1a there. So the maximum number of a's I can take out is just one single a. And then I have 2 c's there, 1 c there, and 1 c there. So the maximum number of c's I can take out is just 1 c. Okay, this right here is my GCF. And then I am removing that from the entire expression. So all I have to do now is I just divide each of these individual terms by 4ac, and I would put those into the square bracket here. So step number 1, 12abc squared divided by 4ac. Well, 12 divided by 4 is going to be 3. That a and that a cancel off, and then 1, 2, and that c will cancel off. So I'm left with 3bc plus 28 divided by 4 is going to be 7. Those a's cancel off, and let me see here. So that's going to be a 7 there, and then I forgot to write the c over here. So if I divide this, this will be positive 9, and I guess those guys will cancel off, and then close that bracket off. And if I combine all these terms, I guess this will be 4ac bracket onto 3bc plus 16. Alright, so there's my final answer for that question. Okay, let's move on to the next few questions now. Factor the following. Okay, so for the next few questions, some of these questions can be done pretty quickly. Notice that I have 3 terms, 1, 2, and 3. So the goal is I need to find 2 numbers that multiply to negative 72, and then those 2 numbers have to add to minus 1. So the numbers that multiply to negative 72, I would assume 8 and maybe negative 9 would work. 8 times negative 9 is negative 72. And then if I take 8 and subtract 9, that gives me a value of negative 1, which matches that middle guy. Okay, so this 2 here generally means I need 2 sets of brackets. X's go in the first term, and then I just copy these numbers into the brackets. So plus 8 and minus 9, there's my final answer. Next one. I need 2 numbers that multiply to negative 10, and those 2 numbers need to add to negative 11. So a good number, I think 10 and 1 would give me 10, but I need negative 11, so let's just put minus signs in front. Negative 10 times negative 1 does give me the positive 10, and negative 10 minus 1 does give me the negative 11. So 2 sets of brackets. Because there's an n squared, that means you need an n in the front. And then once again, just copy these numbers, negative 10 minus 1. And you're done. Next question, I have a negative 12 here. 2 numbers that multiply to negative 12, I have negative 6 and negative 2, and then those numbers need to, actually I think I'll make this into a positive 6 and negative 2. And positive 6 and negative 2 would give me the 4, which matches that middle number. So once again, 2 sets of brackets. This would be n plus 6 and n minus 2. Okay, let's move on to the next one here. Okay, so this question is a little bit more difficult because we have a 2 in front. And notice that the positive 3 and minus 9, we don't have any common factors. So for this question, I'll be using something called the X method. For the X method, I need to look at this 2 here, and I need to find 2 numbers that multiply to 2. And I would just write those numbers underneath that expression. So 2 numbers that multiply to 2, I think that's pretty simple, 2 times 1. And then you need to find 2 numbers that multiply to negative 9. So one could be negative 3 and 3. And then what you have to do now is you just crisscross or create an x. So 2 times 3 would be 6, and 1 times negative 3 will be negative 3. And then 6 minus 3 will give you positive 3, and this 3 must match this middle number there. So I know that the x I've created here is correct. Okay, now to finish the question off, I need 2 sets of brackets. And for the x method, you just read from your x table horizontally, this 2 and this negative 3. So this would be a 2 and a minus 3. And then this blue 1 and that 3 would be just 1 and 3. And all you have to do now is, so this is going to be positive there. So that's positive 3. And the final steps are you just insert an x next to the first numbers. And there's your answer right there. Okay, so that is the x method. Okay, moving on to the next question. Because there's a 5 here and a 19 and a 12, I can't factor anything else, so I will use the x method again. So two numbers that multiply to 5, that's going to be 5 and 1. And then I need two numbers that multiply to 12, so I'll use 4 and 3. And then I create my x. 5 times 3 is 15. And 1 times 4 is positive 4. Does that give me 19? It does. It does match that middle term. So I know that this x is correct. So once again, I just go read out the table horizontally now. Two sets of brackets. So the 5 would go there, and then the positive 4 will go there. The 1 will go there, and the positive 3 will go there. And your last step is just to put an x on the first terms. And that's it. You're done. Okay. For the next question, I have a 4 here and a 49 and a negative 35. I can't factor anything out that's common, so I need to refer back to the x method here. Numbers that multiply to 4, I'll use 1 and 4. And numbers that multiply to 49, I'll use 7 and 7. But I need a negative 35, so I probably need a minus sign on both of those. And let's just use the x method to check here. So 4 times negative 7 is negative 28. And 1 times negative 7 is negative 7. And that gives me a negative 35, which indeed works. So then I just go right into my brackets now. Bracket, 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 bracket. I read up the table horizontally. Whoops. That's going to be 1 and negative 7. So this will be 1, negative 7. And then the 4 and the negative 7 goes in. And finally, I just put x's on the first term. And that should do it. That's my final answer. Okay, moving on to question number 9. Once again, I have a number in front, a 7 and a 49, negative 49. I can't factor anything else, so I'll use the x method again. So numbers that multiply to 6 would be 3 and 2. And numbers that multiply to the 49, negative 49, they'll be 7 and 7. And I'll just put the minus sign up at the top. 3 times 7, that's going to give me 21, and 2 times negative 7 will be negative 14, and that gives me positive 7, which does indeed match the middle term, and I can jump right to the final answer now. 2 brackets, and this will be 3x minus 7 and 2x plus 7. Great. So we move on to the next one here. Now for question number 10, something works out. Something does work out in our favor this time. We can actually factor out a 4. If I factor out the 4, I'll get 4b squared plus 15b minus 25. Okay, so that's the step number 1. Take out the GCF. And then I need to factor out this expression in yellow using the x method. So numbers that multiply to 4 are 1 and 4, and numbers that multiply to 25, I would say positive 5 and a negative 5. And then I just use the x method now. That gives me negative 5, that gives me positive 20, and that gives me positive 15, which does indeed match this middle term. So I can just jump to the final answer here. 2 sets of brackets. Then I go horizontally across. This would be x plus 5 and 4x minus 5, and finally this red 4 just tags along on the outside there, and that's your final answer. I do apologize, I made another mistake here. These x's should actually be b, right? So this should be b, and that should be a 4b, because the answer has b's in our question, not x's. Okay, so my bad on that one. Okay, so move on to question number 11. And for question number 11, we kind of luck out again because I can take out a 5, because 5 is common in all three terms. If I take out a 5, I have b squared. Negative 30 divided by 5 is going to be negative 6v, and 40 divided by 5 is going to be positive 8. Okay, and this polynomial right here is a little bit easier to factor because I need two numbers that multiply to 8 and add to negative 6. So that's going to be, I guess I can have negative 2 and negative 4 because that would give me the positive 8, and that would combine to give me negative 6, so that works. So this is just like, this is similar to the very first few factoring questions, and we just copy these numbers into my bracket, x minus 2 and x minus 4. Okay, let's move on to the next one. These factoring questions, they do take a lot of energy. Alright, question number 12. For question number 12, I notice I have 3 a's there, 2 a's there, and 1 a there, so the maximum number of a's I can take out is just 1. So this will give me, if I take out 1a, I have a squared left minus a minus 90. Okay. And once again, all we're doing is we're just dividing by the GCF each time, and that will give us the expression in the brackets there. Okay. After this, our next job is I need to factor this inside term here. I need two numbers that multiply to negative 90, and those numbers need to add to negative 1. So the numbers that come to my mind are negative 10 and 9, because negative 10 and 9 gives me negative 90. Negative 10 plus 9 gives you negative 1, which matches this middle term there. And let's go ahead and factor this now. A, and then I need two sets of brackets. A is in the front, minus 10 and plus 9. And then we're done. Okay, for the next few questions, you'll notice that I just have two terms now, and when you have two terms, and if you have a minus sign in the middle, this is called the difference of squares factoring. For difference of squares, you always need two brackets, and the first, the signs will be always plus and minus, and then all you have to do now is just take the square root of each term. So this will be 4n, and that will be 3, this will be 4n, and this will be 3, and that one's done. Next one. Once again, I have two terms, so this is called the difference of squares factoring. When I mean two terms, this is one term and that's the next term, so two terms. Okay, so that means I need two sets of brackets. When it's difference of squares factoring, one sign is always positive, one sign is always negative, and then I take the square root of those terms. This will be n, that will be n, this will be 10, and that will be 10, and then you're finished. Alright, moving on to question number 15. Once again, I have two terms, 1 and 2. So this is a difference of squares factoring, and I need two brackets there, 1 plus and 1 minus, and then I take the square root of each of those terms. This will be n squared, that will be 10, and that will be 10. And then we'll leave it at that. Alright, so remember, we need to have perfect squares, right, in order to do the difference of squares factoring. I have two squares here, two terms, so I need two sets of brackets. I need a plus and a minus, and then I just take the square root of each term. This will be n squared, this will be 1, and that will be n squared, and that will be 1. Now you have to be careful with this term right here, n squared minus 1. We can still factor that because that's still two terms. And if I have two terms, I can do a plus and a minus, but the reason why I can factor this is because I can definitely take the square root of each of these terms, right? So that'll be n, 1, n, and 1. So then I have just n squared plus 1. Now be careful, I can't factor this x squared plus 1 because there's a plus sign there, right? In order for me to apply the difference of square factoring, I always need to have a minus sign in between the two terms. Okay, that's that one, and then now let's move on to the next section here. Okay, so let's get going here for linear equations. Okay, so the goal with linear equations is you want to keep the variables on one side and the numbers on the other side. So throughout this video, I'm going to say things like the left-hand side, and I will also say things like the right-hand side. Okay, so once again, the goal is to keep the letters on one side, and we'll keep the numbers on the other side. Okay, so for this to work, I have a -6 there, and I want to move that to the right-hand side, so that's going to be 14 plus 6, and this will be the 4b. 14 plus 6 is 20, and this is 4b, and then I divide both sides by 4. I get b equals to 5, and that's it. Okay, moving on to the next question here. I have a -10, and if I bring that to the other side, the sign changes, so this would be 2 plus 10, and then -12m on the left-hand side. 2 plus 10 is going to be 12, and this will be -12m. And then I need to just divide by this -12, divide that by -12, and this is m equals to -1. Okay, moving on now. There's a +5 here. If I move that to the other side, if I move that to the right-hand side, this will be -13 minus 5. So this will be -18, and this will be 3b. And then I divide both sides by 3, divide by 3, so b would equal to -6. For the next one here, on the left-hand side, I have a 4w and a positive 3w, so 4 plus 3 will be 7w, equals to 35. And then I have to bring this -7 to the other side, that'll be positive 7. So 35 plus 7 is 42, and this would be 7w, and then I divide both sides by 7. W equals to 6. Okay, let's move on. Okay, for question number 5, I have a 4g on the right-hand side, so let's bring that over. So that's going to be a 12g minus 4g. And then I have this at -72, so let's bring that to the other side, to the right-hand side. Once again, we're trying to keep the letters on one side and the numbers on the other side. So 8 plus 72, that's going to be 80, and 12g minus 4g, that's going to be 8g, and then I can divide both sides of the equation by 8, and then g would equal to 10. So those 8's just cancel, giving me the g. Okay, moving on to question number 6 now. I see variables on the right-hand side, so let me just combine that. -2m minus m is going to be -3m. And then I have this 3 there, and I'll bring that to the other side, and that's going to be -12 minus 3. So that's going to be -15, and this is going to be -3m. And then I divide both sides by the -3. Those cancel, giving me an m, and this gives me a positive 5. Okay, moving on to question number 7 now. Question number 7, I see a set of brackets, so I can just distribute that. That's going to be -3d minus 6, and that's going to be a 6 on the left-hand side. This -6, if I bring that to the other side, that's going to change signs, so I'll have 6 plus 6 equals to -3d. 6 plus 6 is 12, and then I divide both sides of the equation by -3, and this gives me d equals to -4. Okay, moving on to question number 8 now. Just trucking along here. I see brackets, so let's get rid of the brackets by distributing here or rainbowing. This will be -18n plus 15, and this will be 75 on the left-hand side. I have a positive 15 there. I can bring that to the other side because I want to have the numbers on the same side here. So that'll be 75 minus 15 equals to -18n. Sorry, I made a mistake here. What did I do here? Sorry, this is supposed to be -15. So let me start all over again here. Okay, so once again, I just need to, for this question, I just need to distribute the 3 into the expression here. So this will be -18n minus 15, and this will be 75. I have a minus 15, so if I bring that to the other side, that's going to be 75 plus 15, and this will be -18n. This will be 90, and then 90 divided by 18 gives me Does that give me anything nice? 5, I believe, yes. So negative 18 divided by negative 18. 18's cancel, so n would equal to 90 divided by negative 18, which will be negative 5. Okay, let's move on here. Let me just delete some of this so I have a little bit of room here. Okay, so these questions aren't too bad. I need to distribute one more time. This will be negative 3 minus 18r equals to 14 minus r. Okay, this negative 18 I'm going to bring to the other side. So that's going to be negative r plus 18r. And then this 14 I will bring to the other side here. So that will be a negative 3 minus 14. So this will be 17r, and this will be negative 17. Divide both sides by 17, and I get r equals to negative 1. Okay, let's move on to question number 10. So for question number 10, the concepts are still the same. It's just the numbers and expressions get a little bit longer here, but we still distribute or rainbow. That'll be negative 12m. And this will be plus, it should be minus 8. Minus 5 equals to 2m minus 3m plus 9. Alright, let me just combine these terms right here. 2m minus 3m will be negative m plus 9. And then over here I have negative 12m. And if I combine these terms, negative 8 minus 5 is going to be negative 13. Okay, and then I will highlight this negative 12m and I'll bring that to the other side. So that's going to be negative m plus 12m. And if I highlight this positive 9, if I bring that to the other side, I'll have negative 13 minus 9. So this will be positive 11m, and this will be negative 21. And then if I divide both sides by 11, I will get m equals to negative 2. Alright, so that's part 1 of linear equations. Let's move on to part 2, which deals with decimals, I guess. Okay, this one right here, we've seen this a few times in class here. I will highlight these decimals there, and I'm actually going to change those into fractions now. That's 1 over 4, bracket 8y plus 4, minus 17 equals to negative 1 half, bracket 4y minus 8. And then I will just rainbow the 1/4 right through. So think of this as 8 divided by 4. That's going to be 2y. And then I have 4 divided by 4. That's going to be plus 1. And then minus the 17 equals to, well, what's 4? Sorry. What's 4 divided by 2? Well, that's going to be 2 with a negative sign, so negative 2y. And then I have this negative 8 divided by this negative 2. That's going to be positive 4. Okay. And after that, I just collect like terms, bring this to the other side, and combine that with that 2. So if I bring that over, that's going to be 4y. This right here is going to be minus 16 equals to the 4 there. And then if I bring this negative 16 over, that's going to be 4y equals to 20. And then divide by 4, divide by 4, y would equal to 5. Okay. All right, let's move on to question number 2 here. H over 3 plus 2 over 9 equals to 5 over 6. Okay, there's a few ways you can do a question like this. I see a 3, a 9, and a 6. So if I look at the 3, 9, and 6, the least common multiple between 3, 9, and 6 is going to be 9. So, no, it's not 9, sorry. Is it 18? Yeah, it's actually going to be 18, right? So the multiples of 3 are 3, 6, 9, 12, 15, and 18. The multiples are 9 and 18. The multiples of 6 are 6, 12, and 18. So the least common multiple has to be 18. So I will multiply everything by 18 here. So times that by 18, times that by 18, and times the second term by 18. Okay, so let me just delete this here, and let's just ask ourselves, what is 18 divided by 3? Well, that's going to be 6, so 6h. And then what's 18 divided by positive 9? That's going to be positive 2, and then 2 times that 2 would be positive 4 equals 2. Well, what's 18 divided by 6? That's going to be 3, and then 3 times that 5 will give me 15. All right, so now we have a very nice expression here. This will be 6h equals to, this will be 11, I guess, and then divide both sides by 6. So my final answer would be those 6 cancel off, h equals to 11 over 6. Great, let's move on now. Let's delete all this. Okay. For question number 3, the quickest way that I can do this question is I can highlight this 2 there, and I can times both sides of the equation by 2. So times by 2 there and times by 2 there. Negative 5 times 2 is going to be negative 10, and then these 2's will just cancel off, giving you m plus 3. Now remember, with linear equations, if you times one side by a number and times the other side by the exact same number, you're still balanced, and that's still mathematically correct. You haven't changed the problem. Alright, so if I bring the 3 to the other side, this will be m equals to negative 10 minus 3, and this is m equals to negative 13. Okay, so hopefully that's okay. If you didn't quite understand why I was multiplying by 2 at the beginning, I mean, I could also put this negative 5 over 1, and if I highlight this 2 and this 1, the LCM, just like the previous question, between 2 and 1 is going to be 2, right? So we're just multiplying both sides by the LCM, and this works out very nicely because those cancel off, and then that's going to give you negative 10, right? So that's how we can kind of simplify the question a little bit quicker if I have fractions. Same thing with number 4. If I look at this 3 and this 6, the least common multiple between 3 and 6 is actually going to be 6. So I can multiply both sides by the LCM, which is 6. And then I just do the math. What is 6 divided by this 3? Well, 6 divided by 3 is 2. And then this whole thing will just tag along. Equals 2. Well, 6 divided by 6 is 1. And then I just multiply these terms. 2 times 2 is 4, so this will be 4 bracket n minus 2 equals to 1. And then I rainbow right through. That's 4n minus 8 equals to 1. This 8 goes across, so 4n equals to 9 divided by 4 divided by 4. Those 4's cancels. This means n equals to 9 over 4. Final answer. Okay, let's move on. Okay, for question number 5, let's pretend there's a 1 under that 3 there, and ask yourself, what is the least common multiple between this 5, that 3, and that 1? Well, the least common multiple is going to be 15, so I multiply all 3 terms by 15. And what I recommend doing next is when you multiply the 15 onto every single term here, I would do the division step first. Ask yourself, what is 15 divided by 5? That's going to be 3. So 3 times 4c. And then what is 15 divided by this 3? That's going to be 5. So that's going to be negative 5 onto the 4 plus the 5c equals to 3 times 15, which is 45. And then we need to multiply now. 3 times 4 is going to be 12c. And then we distribute this across. That'll be minus 20 minus 25c equals to 45. I combine this 12c and that negative 25c. And that's going to give me negative 13c. And this negative 20 I can bring to the other side. So that's going to be 45 plus 20, that's going to be 65 equals to negative 13c, and then divide both sides by 13. I actually get a nice answer here, I think. Sorry, just doing the calculations on the side there. 65 divided by negative 13 gives me negative 5. So that's my final answer there. Okay, moving on to question number 6. Number 6, I have an 8 and a 4, so the least common multiple between 8 and 4 has to be 8. So I can multiply both sides of the equation by 8. This 8 and that 8 will cancel, so this will give me m plus 5 on the left-hand side, and then ask yourself, what is 8 divided by 4? That's 2, and then 2 times that 7 is going to be 14. So then m here would be, well, I bring the 5 across, so this will be 14 minus 5, and then that means m equals to 9, and then we're done. Okay, let's move on to the final few questions here. So again, I'm running out of space, so let me just delete all this. Okay, there's a 2 here and a 3 there, and there's a 1 over 1 there. So the least common multiple between 2, 3, and 1 is going to be a 6. So that means I need to multiply that by 6, this by 6, and that by 6. Alright, so 6 divided by 2, that's going to be 3. So 3 bracket t minus 1. And ask yourself, what is 6 divided by 3 there? That's going to be 2. And then 2 times 2 is going to be negative 4. And 6 times 1 is just going to be 6. Okay. And then just rainbow this across. This will be 3t minus 3. This will be negative 4t minus 4, and that will be 6. And then combine those guys. 3 minus 4t is going to be negative t. And that 3 and that 4, that's going to be negative 7 equals to 6. I can bring the negative 7 across, so that'll be 6 plus 7. This will be 13 equals to negative t. And then if I divide both sides by just this negative t, which is the same thing as, sorry, if I divide both sides by negative 1, that will get rid of this negative sign, and I'm left with t equals to 13 divided by 1, which will be negative 13. Let me just see if I made any mistakes with this question here. Just going back, just 1 second. Alright, that looks about right. So let's just move on to the next one here. Question number 8. Okay, for question number 8, one of the little tricks that you have to know is called the crisscross method. And how the crisscross method works is that if you have like a fraction, like 1/2 equals to 2 over 4. I mean, these two fractions are equivalent, and what I do is I just highlight the denominators and I can move them to the opposite numerator, kind of like the x method. So this would be 1 times 4 equals to 2 times 2. So this 4 just move, the 4's and the 2's just move across. And this is still true because we know that 4 equals to 4, so we can definitely take the numbers on the bottom and move them to the opposite numerator. So if I do that here, this d minus 2, if I move that to the opposite numerator, that's going to be 2 bracket d minus 2. And then this d minus 7, if I move that to the opposite side, that's going to be 3 bracket d minus 7. Okay, and then we just distribute here. This would be 2d minus 4 equals to 3d minus 21. And if I bring this d over, if I combine those d's, this will be 3d minus 2d, and this will be negative 4 plus 21. This will give me d, and negative 4 plus 21, that's going to be 17. So d equals to 17 there. Okay, let's go on to part 3. For part 3, I have another linear equation, but I need to solve for x. So if I need to solve for x, that means I need to get x by itself. And instead of giving you a lot of numbers, we just give you straight up variables, but the concepts are very similar. So here's my x right there. I need to get that x by itself. I have this d here, so let's move that to the other side. If I move that to the other side, that's going to be negative d equals to cx. And then after that, I just divide by this c and divide that side by c. Those cancel, giving me the x. So my final answer is going to be a plus b minus d divided by c. That's my final answer. Okay, moving on to question number b now. I have a 9 here, so I can multiply both sides by 9. So this will be 9c equals 2. Well, that 9 and that 9 will cancel off, so that's going to be 5 bracket x minus 32. And then I can divide both sides of the equation by 5. So those 5's will cancel, and now I'm left with 9c over 5 equals to x minus 32. And then this negative 32, if I bring that to the other side, if I bring that to the other side, it's negative, so that'll be positive, equals to x. And that's my final answer there. Moving on to question number C. Now question number C is a little challenging because you have to look at your denominators here, and you have to ask yourself, what is the least common multiple for 2a, 3b, and 1? And a very quick way to find the LCM for a question like this, and actually to find a common multiple for any of these fraction problems, is you just take the denominators and you just multiply them together. So that will be 6ab. So that means I need to times everything by 6ab. Okay, so I can times this by 6ab, times that by 6ab, and times this by 6ab. Okay, and then let me just kind of delete these guys for a bit. Okay, ask yourself, what is 6 divided by 2? So 6 divided by 2 is going to be 3. And you'll notice that this a and that a cancel, so I'm left with 3bx. And then if I do this 6 divided by that 3, that's going to give me 2. And then the b's will cancel, so I'm left with 2ax equals to 6abc when I multiply all that out. Okay, so if you're not sure how I got this 3bx, let me just kind of repeat that one more time. I had 6ab, and I was multiplying that with x over 2a. Okay, so the first thing I did was this a and that a cancel off, and then I found out this part, which was 6 divided by 2. That gives me the 3 there, and then the b and the x that's left over. So that's how I get the 3bx. Okay. Now, if I look at this term, these two terms in blue, both of them have an x term, so I can factor out the x. So that'll be 3b plus 2a equals to 6abc. Alright, so I factor out the x there, and then I can divide both sides by the 3b plus 2a. And those will cancel, giving me just the x. So I'll move the x over here now, so then that means x equals to 6abc divided by 3b plus 2a. Okay, let's move on to the next one here. Question number D. Okay, so question number D, I see brackets, so I'm going to just delete that. And I'm just going to distribute this right across. This will be ax minus ab plus cx plus cd equals to e. I'm going to rearrange these terms right here. I'm going to put them right next to each other so that it's very clear that we can factor something out. And then these terms in blue, I'm going to move those to the other side. So that's going to be e plus ab minus cd. Alright, so I can factor out the x's here. So that'll be x onto a plus c equals to e plus ab minus cd. And then finally I can divide both sides by ac, a plus c. These guys cancel off, so let me just delete this now, and then move the x over, and that's your final answer right here. X equals to e plus ab minus cd all over ac. Okay, let's move on here. Question number 2, make v the subject and solve for v. Okay, so here's my v, I need to solve for that. So this gt squared, let's move that to the other side. So that's going to be d minus gt squared equals to vt. Okay, now I have this t, I need to get rid of that. So since v and t are multiplying, the opposite of multiplying is dividing. So I divide both terms by the t. and those guys cancel off, and then just v equals to d minus gt squared over t. If you want to simplify this a bit more, this is the same thing as d over t minus gt squared divided by the t. And I guess you can divide those t's, so that would be just 1t over here, and then that would be it. Okay, let's move on to the next question here. Word problems. Okay, so the length of a rectangle exceeds its width by 4 inches. Find the dimensions of the rectangle if its area is 96 square inches. Okay, so let's just draw my little rectangle here, and once I draw my picture, we'll try to create some equations here. So let's just say this is the length, and that's the width. Now it says the length of the rectangle is bigger by 4 inches. Okay, so if I just write the expression length equals to width, this means the length and the width are equal. But the length is actually 4 inches, is bigger by 4 inches, so I need to insert this 4 by doing L equals to W plus 4. And if you read this from the left-hand side to the right-hand side, this means the length is the width plus 4 inches. Okay, so that's equation number 1. The second equation is that the second equation comes from the fact that the area is going to be 96 square inches. So that means W times L equals to 94. Okay, so my second equation is going to be 94 equals to W times L. Okay. Now once you've created two equations, you want to do a substitution step here. So if I highlight this blue L there, I'm going to replace that with this L, and that L equals to W plus 4. So what that means is that I have 94 equals to W, but instead of writing this L, I'm going to write bracket W plus 4 because L equals to W plus 4. Okay, and after that, I just do a little distribution step here. This will be W squared plus 4W equals to 94. And from here onwards at the grade 9 level, what you can do now is you need to guess numbers such that if you take that number and square it and add 4 times that number, you get 94. So one number that I'm going to check right away is going to be the number 8. Ask yourself, does 8 work? And this will be 8 squared plus 4 times 8. This is going to be 64 plus 32, which equals to 94. So we know that if W has the value of 8, that 8 will work. So once you get to this step right here, you need to do a guess and check. You need to find a number such that when you square that number and add 4 times that number, you get 94. So I will just guess the number 8, because I know the answer was 8. And I noticed that if I plug in 8, I do get 94. So my width is going to be 94, or sorry, my width will be 8. And if I go back to this expression right here, or the first expression, I'll use my first expression actually. L equals to W plus 4. I know that my W is going to be, my W here is going to be 8. So if I do 8 plus 4, that's going to be 12. So my length is 12 and my width is 8. Okay, let's move on. I'm actually going to skip this one because that requires a little bit of squaring. Alright, so the next question, actually these questions aren't so great for the grade 9 level, but we'll just work through this one here, and then hopefully we'll gain a little bit more confidence with some of these word problems. The height of a triangle is 5 less than its base. Okay, so let's just draw a little triangle here. This is the base, and this is the height. Okay, so I know the height of the triangle is 5 less than its height, so if I want to write a mathematical expression for that, I can start off by saying that the h equals to the base. Now, if the height is 5 less than its base, then I have h equals to the base minus 5. Okay. So if you read this from left to right, this means that the height is equal to the base minus 5. So that means the height is going to be 5 less than the base. Alright, the other equation I have is the area of the triangle is 42 square inches. Okay, so I know the area of a triangle is going to be base times the height divided by 2, and that has to equal to 42 inches. Now ask yourself, how do I get rid of this 2? Well, I multiply both sides of the equation by 2. Those 2 can cancel, and then I have if I move this up here, I'll have base times the height equals to 84. Okay, so I'm just getting rid of that. I'm just getting rid of the 2 in the denominator there. Okay, so just like the previous word problem, I need to do a substitution step here. And if you see this h right here, I'm going to replace that blue h with b minus 5. So this will be b times b minus 5 equals to 84. And then I just distribute here. I'll do that on the side here. So b times b is going to be b squared minus 5b equals to 84. And from here on, I'm just going to tell students at the grade 9 level just to guess and check. You want to find a number such that if you square it and then minus 5 times that number, you'll get 84. And if you actually try the number 12, if you guess and check and use number 12, 12 squared minus 5 times 12, that will give you 84, because I did try that out. So your base is going to be 12, and then that means your height is going to be, well, if that's 12, 12 minus 5 is going to be 7, so that means the height is going to be 7. Okay. Once again, if you want to go from this step to that step, you need to guess a number. And the number that I'm going to guess is going to be the number 12, and 12 did work. 12 squared minus 5 times 12, that does give me 84. Okay, finally this last word problem here. A bag contains 30 coins, all of which are either quarters or dimes. The total value of the coins is $5.85. How many of each kind are there? Okay, so step number 1, a bag contains 30 coins, and they're either quarters or dimes. So let quarters be Q and let dimes be D. So Q plus D has to equal to 30. And then so the number of quarters plus the number of dimes has to be 30. And then how do you use this 585? Well, I know that 585 has to equal to the value of a quarter, which is 0.25 times the number of quarters plus the value of a dime, which is 0.1 times the number of dimes, right? So that will give you 585, right? If you take the value of the quarters times the total number of quarters plus the value of a dime times the total number of dimes. Okay, so going back to this first equation right here, let me just move this D to the other side. If I do that, I'll get Q equals to 30 minus D. And the reason why I do that is because I'm gonna substitute this Q with this Q right there. So this 30 minus D is gonna change for that Q. So I do that, I get 0.25 bracket 30 minus D plus 0.1 D equals to $5.85. Okay. So once again, this is more distribution here. I can use a calculator here. 30 times 0.25, that's going to give me 7.5 minus 0.25D plus 0.1D equals to 585. If I combine these terms here, negative 0.25 plus 0.1, that's going to be that's going to be 7.5 minus 0.15D equals to 5.85. And then if I bring this 7.5 over, a lot of math here, this will be 5.85 minus 7.5, and that's going to equal to negative 0.15D. $5.85 minus $7.50, that's going to be negative $1.65 equals to negative 0.15d. And then finally, with linear equations, I can divide both sides by negative 0.15, divide that by negative 0.15, and that means the number of dimes is going to be divide by the wrong number there. I get 11 dimes right there. So 1.65, negative 1.65 divided by negative 0.15 gives me 11 dimes. So if I have 11 dimes and the number of quarters, so I know that the number of dimes is going to be 11, and I have 30 coins in total, so 30 minus 11, that's going to give me 19 quarters. So quarters will be 19 and the dimes should be 11. And one good way to kind of check your work here is by doing 19 quarters times the value of a quarter, which is 25 cents, plus 11 dimes times the value of a dime, which is 10 cents. That does give you 585. I just verified that with my calculator, so I know those numbers would do indeed work. Okay, so that's it for this review. There's another section on linear inequalities, and then we'll be done. But that concludes this video. All right, see ya.